want to welcome everybody to our meetup tonight, the Cloud Native East Bay. I know there's another East Bay Cloud Native, but we're all the same. And I just want to, thank you all for attending. And tonight we have, courtesy of Microsoft, two really great speakers. Jessica Deen, who I just discovered last year, and I realized how amazing she is. She's a CrossFitter. I'm a CrossFitter, so I love that about her. I saw you on the games. That's how you, exactly. It's like religion. But the thing is, this is like my second journey with running Kubernetes. We're doing it, we're learning it, we're running it, starting to run it here at Adobe Ad Cloud. And there's been, a lot of amazing growth in it. And just to kind of be part of this community, to kind of see that growth and just see the community really just develop is just really amazing. And so tonight we really kind of decided to do two different topics. I think Jessica's has got a really, practical talk that I think you could really take and run away with and learn and utilize. And then Lachie's going to talk a little bit more about Kubeflow, things that are a little bit more, coming in the future, but it's still an exciting to see this develop. So let's just kick this off, and we'll have Jessica Deen kick us with DevOps with Kubernetes and Helm.
Awesome. Thank you very much for having me. Thank you. How's everyone doing? All right. Try this one more time. I know it's the end of the day, but let's try with a little more enthusiasm. How's everyone doing? That's awesome. All right. So something I started, I just got back from Build last night. Build is Microsoft's developer conference. There's 6,000 people there. We streamed it online. Something I started doing officially as of this week is I now take a selfie with my audience wherever I go speak. So everyone has to give me their best smile, and you guys are all going to be famous and end up on Twitter, okay? Lachie, do you want to get up here and stand next to me? Or all right, 1, 2, 3. Awesome. Thank you, guys. Give yourself a round of applause. So that is officially your first homework assignment, and you passed with honors. Perfect. I'm going to turn this off so I don't have any kind of mic interference. So my name is Jessica Deen, and I'm a cloud developer advocate for Microsoft. Today we're going to talk about DevOps with Kubernetes and Helm. Somebody in the audience did mention they had seen a session at Build. I apologize. It's probably going to be very similar content and very similar jokes. I travel quite frequently actually giving these talks. A little bit about me is my background is Linux, open source, containers, and IT operations. I'm actually not what I would formally consider myself to be. I wouldn't consider myself a traditional developer. And for the longest time, I would say I'm not a developer. And then I realized I'm kind of in this new space of I'm actually developing infrastructure and architecture. But for other IT operations people, we're all in this space, right? So we're going to talk a little bit about that. On the first bullet point, I often get asked why I don't have DevOps in my talk, because in every talk, or why I don't have DevOps in my bio. In every talk I give, DevOps is always a component because I happen to work on a DevOps team, but I don't include it in a bullet point because DevOps is in everything I do. It's a mindset, it's a culture, it's a choice. And we'll talk about that. And it's important because DevOps practices actually set the stage for container orchestration, for tools like Kubernetes, and ultimately tools like Helm. I'm also super into CrossFit, as was mentioned earlier. So I'm usually in any city or any country I'm in, I'm either in a hotel gym or a CrossFit gym, probably upside down doing handstand push-ups or scaring somebody who's around me. I'm also a huge Disney and Star Wars fan, and I don't say that lightly. I actually have Han Solo's blaster tattooed on me, Luke Skywalker's hilt. I talk passionately on Twitter, even about Doctor Who, because I have a Doctor Who, Star Wars, Princess Bride, Zelda, fandom crossover tattoo. You name it, I just love geek, and I love having fun. I'm also a member of what we call the League of Extraordinary Cloud DevOps Advocates, or as we like to call ourselves, the League. You can follow us on Twitter at I think it's at the LOECDA.com or at LOECDA. You can also reach out to us by using that hashtag. When you do, it actually lights up in our Teams room. But what's cool is we're actually led by Donovan Brown, who was also in the Build keynote a few days ago. And then we also have Damian Brady and Abel Wang, as well as Stephen Morawski. And what I love about this picture is we really embody kind of the new image of this DevOps world. Donovan, Damian, and Abel all have developer backgrounds, while Stephen and myself all come from an IT operations background. but we're able to work together and really deliver amazing value to customers and to end solutions without this wall between us. So we'll talk a little about that. And as awesome as the league is and as much fun as we have, we're actually only a small part of a much larger team at Microsoft, which is the Cloud Developer Advocacy team. We are around the world. We are global. There's about 60 of us, and we specialize in everything from machine learning to AI to IoT to Linux, open source, you name it. There's somebody on our team that does it, which is really powerful. I recommend using this hashtag or following us at Azure Advocates. And if you have a question for anything, whether it's even how do I get started in my career, or I'm working on this project, do you have any recommendations? Reach out to us. Every single person on this team absolutely loves what they do. Most importantly, it's not about bleeding blue or being Microsoft. It's about the fact that we all just genuinely love to code. So without further ado, we're just going to dive right into today's talk. So I mentioned how we're going to set the stage kind of with a DevOps talk. Before we do, we have to talk about the current state of our industry, right? We have to talk about the current state of technology. We are going digital, or as some would argue, we have gone digital. This was a study that was done by Gartner, I believe about 2 years ago now at this point. But they estimated that 1 million devices per hour will be coming online by 2020. 1 million devices per hour, 2020. That's less than 2 years away. They also estimated by that same year, the average age of an S&P 500 corporation will be 12 years of age. Compare that to 1960, where the average age was 60 years old. Companies are getting younger. We're spinning up faster. We're having more and more devices come online every hour, every day. So from IT, ops, or developer, we have this really new challenge, right? There's just rapid growth going on. And they also estimated that 60% of computing will be done in the public cloud by 2025. That's about 7 years away. And we're already seeing such a shift to the cloud, right? You have everyone talking about the cloud. You have your grandmother talking about the cloud. But when she does, it's air quotes, cloud. Fun story actually about the cloud and about that particular comment. I'm always asked wherever I go when somebody finds out that I work for Microsoft, do you know where the cloud is? Do you know what the cloud is? Well, actually I do. Like I work for Microsoft. Our cloud is Azure. And so that same conversation happened when I was at a little breakfast shop in Paris in March. I'd been there for Tech Summit Paris. And so I noticed, by the way, my French is awful. So when I was in Paris and I'm hearing somebody actually talk English, I lean over and I start having conversation. They were there on spring break. I told them I was there for work. They immediately look, do you know where the cloud is? I do. It's Azure. We have cloud around the world. They're like, no. I can now say I met the cloud, and the cloud's name is Jessica. Like, all right. So just cute story, but it's true story. You have everyone talking about the cloud. So how do we kind of deal with this rapid growth, this momentum, and this increase in change? First off, how many people in the room would identify themselves as a developer? How many people feel comfortable saying that they're IT or operations? So we actually have a healthy balance in this audience. So in order to set the stage, we really kind of have to start talking about what each perception is, right, from developer or IT. For the developers in the room, and don't worry, IT, I'm going to get to you. We're going to have our moment too. Tell me if this sounds familiar. I need to create applications at a competitive rate without worrying about you, IT person. Or the application runs smoothly on my machine, but when I give it to you and you run it on your server, it breaks. It's your problem. Or my productivity and application innovation become suspended when I have to wait on you. You, IT person, are the bottleneck to my success. Sound familiar? And then here's what we hear from IT. I told you you'd have your moment. Developers, listen. So from IT, we think I need to manage servers and maintain compliance without disruption or with little disruption. I can't just give you access. You can't just RDP over and set up whatever we want to run for the web application. But along those lines, I didn't write the application. I'm not a developer, or in the traditional sense, I'm not a developer. So I'm unsure of how to integrate this application since it's unfamiliar. I require help from you. I need to work together. And then also, I'm unable to focus on both server protection and application compliance. I can't worry about the security of my server and the security of your application. So with this rapid growth, with this innovation, how do we deal with these pain points, right? regardless of whether or not you would say you work in IT, if you touch code, if you touch software, if you touch servers, if you touch equipment, you work in IT. So these stress points are all of ours. This is universal. We all have to worry about security threats. We all have to worry about efficiency. And we all have to worry about supporting this innovation that we just talked about. So that's where the cloud comes in. That's why everyone is talking about the cloud. It's the new way to think about data center, right? The traditional model. You had dedicated infrastructure for each application. Your hardware was purpose-built for each project. The infrastructure and operations teams were distinct and separated. I often use the analogy of it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room. No one wants to come together and dance together and work together. And then you also, the processes and configurations you had were customized. They were specifically tailored for that project, for that delivery, for that hardware. But that model isn't scalable, right? We talked about this rapid growth. How can we move with that momentum? So that's where the cloud model comes in. Now you have loosely coupled apps and microservices, right? You have industry standard hardware across the board. You also have processes and configurations that are standardized. And now the service delivery teams you have are DevOps focused teams. They're focused and passionate about making sure we come to that middle of that dance floor. We all have a good time together. So that sets up the DevOps conversation, right? It's a three-part conversation. We've already identified people. We're going to touch a little bit on process, but then there's also products that goes into it. And we're very specific when we use these words. My boss actually, little Dono dude, or Donovan Brown, he's actually the one that authored this quote, and I love it. But what a lot of people don't know unless they've heard him talk about it, someone on our team talk about it, or myself, is that he actually spent 30 days coming up with this quote because he wanted to make sure that every single word in there was something that he could stand behind and his team could stand behind. We're explicit even when we use the word products. So DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. If you're not delivering value, what are we doing? You can release new features, you can roll out new updates, and have new patches, but if your users don't care, or if they're not what your users want, is there really value in it? And when I said that we're specific on products, I often like to use another analogy of it's like a house. If you're trying to build a house, you can have your hammer, you can have your miter saw, your nails, your screwdrivers, all these different tools, but without the right products and process and people involved, you're not going to have something of value, right? You're not going to be able to have this house that ultimately can support future growth and future generations. So I mentioned we're going to talk about the plan. Here's what a plan looks like. And you'll notice that it's cyclical, right? We want to keep things moving. We want to keep things repeating. You start with a plan. You move into your develop and test. That's where you're going to do your continuous integration or your unit test and your build. And then you hand that off over into release or your release management stages. You'll have things like continuous deployment in there. You'll have where it's releasing out into your environment. But it doesn't end there. Because again, how else are you going to know if you're delivering value? We have to monitor and learn. We have to have something that gives us insights and telemetry into figuring out what our users are doing, where our users are, and if our users care about what we're releasing. So these are standard DevOps practices. And again, I'm setting the stage for this because this really explains why Kubernetes and why orchestration, why these tools are so valuable. You have things like infrastructure as code. That way it's repeatable. Anybody who comes from the traditional sense, especially from IT and operations, we're doing gold master images and you're having clones and you're setting up this dev server and this QA server, this staging server and prod. And you think the software is up to date on prod just as it is across all the others. But then when the developer gives you your application and it breaks, we have a problem. So having infrastructure as codes allows us to mitigate that, right? Then you have continuous integration, deployment, testing, performance monitoring. Each one of these practices fits into one of those 4 buckets. Benefits of implementing DevOps, and the study is old. Unfortunately, I was traveling yesterday. I still need to update a lot of this data. But even from almost 3 years ago, this data is still really impressive. The most important part is the right-hand side. When you implement DevOps, you're able to deploy code up to 30 times faster and with 200 times shorter lead time because everything's in a pipeline. Everything's cyclical, right? And then you're also estimated to have 60 times fewer failures. And in the event of a failure, you're actually able to recover 168 times faster because you can roll back, you can revert back to a previous commit. You're now looking at version control. All these things that are standard to perhaps the developers in the room, but IT operations, source control, version control, that's still really new for us. So now we're going to actually get into the meat and potatoes of this conversation, and we're going to talk about orchestration. This is a funny video. We recorded it last year at KubeCon in Austin. There was a woman who actually stood off to the side after about the 5th take. We went through about 8, and she just sat there and watched us record it for about 3 different takes. She mentioned that she worked as one of the crew members of the conference. She wasn't technical, couldn't even pronounce the word Kubernetes, had no idea what container orchestration is. And after watching it, she's like, I think I finally get it. It's that when something fails, it's still up. Like, yes, that's it. So it's meant to be silly and funny, but let's go ahead and watch.
Hi, my name is Jessica Deen, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got green screen and an amazing producer.
This is some really good virtualization.
So
What are we doing today?
we are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. Add Docker file. Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers,
So,
especially for the sake of time.
there we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Got to be efficient. Always efficient. Look at all these apps we're deploying. This is going to be the best node ever. I'm so excited for this node. Look at this. So pretty. I can't wait to see this node done. It's going to be my favorite node ever.
Best one. Hey, Zach. What's up, man? What are you guys doing? We're talking about container orchestration.
Yeah, we just deployed a node on the server.
Right,
We just
I
deployed
mean,
a bunch of
I
apps.
really neat, but do you mind if I
Well,
wait?
actually- Now we have node failure. What are we going to do?
I don't know. We actually have a Kubernetes.
That's right.
So, want to see what happens?
Yeah, so let's go over to our other node. Look at that. Thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second node. This is fantastic.
Magic.
I really hope that this helps explain how orchestration works. Thanks for watching social media.
Thank you, thank you. Of course, that's meant to just be funny and kind of an icebreaker, but pay attention to some of the key words that I jokingly said, right? I talked about bin packing, I talked about schedulers. All of those words are actually parts of Kubernetes and orchestration. We'll talk a little bit, but first let's talk about containers. Why container? We talked about the pain points for developers and for IT. So for developers, it enables this write once, run anywhere concept. And then for operations, most importantly, it addresses portability, portability, and portability. I'm able to now standardize the development experience across all my environments, across dev, across QA, and prod. Here's what a container actually is. I'm often asked, and I've delivered various versions of this talk, I always still get asked, Kubernetes sounds awesome, but what's a container? So containers is flat out operating system virtualization. Think of traditional virtual machines, that's hardware virtualization. So with containers, you have your hardware, you have the kernel, you have applications kind of sitting on top of your kernel, but then you have a little container that's like an encapsulated runtime environment sitting on top of that. Traditional virtual machine, obviously you have your OS and your applications sitting on top of the OS. It's a lot bigger of a system. Windows Server containers takes that a little bit differently, where again, it's still sitting on top of the hardware. Hyper-V containers offers isolation plus performance. So you're actually getting a little bit more security out of Hyper-V containers because you're also encapsulating the kernel and the runtime environment. But still, what is a container? So first off, it's not a real thing. It's an application delivery mechanism with process isolation, and it's based on actually Linux kernel features. So especially if your background is a lot more like Windows focused, some of these names and namespaces, C groups, all of these are very Linux kind of terms, but they still play a purpose. So namespaces, which you'll also kind of hear in Kubernetes, is what a process can see. You have your PIDs, you have mounts, you have network, but then C groups is what a process can use. And again, you'll also see that in Kubernetes deployment files. You'll see what you can assign to that particular process. You can assign your CPU, you can assign memory, so you can actually limit hardware to that container. Now, it's great that we've identified what a container is, but what is Docker? Here's this Kubernetes tool. I thought Docker is a different company. Docker is an open source container runtime. It can be used on Mac, Windows, or Linux support, and actually, as of the latest Edge versions on both Windows and Mac, I would assume Linux, but I haven't tested it, you actually, in the Edge support, as of, I believe, 1803, and I may be wrong, you can now actually have Kubernetes running locally on your system as well. It's also a command line tool, but most importantly, the Docker file format is the standard image for building container images, and it uses a layered file system. So a standard Docker file kind of looks like this. You're kind of identifying your runtime environment. You give it a from for a base image. You copy your commands or you add certain files. You can even do apt-get to install all these different packages. And then you would have your command or your entry point for what you want to run. So everything is fully encapsulated. And here's how that, I mentioned it's a layered file system. So here's a visual of how that looks, right? You have your base image for your from. Then you have all these different layers that essentially, as it's building, as it's pushing for what it needs to make the smallest footprint necessary, it's caching these kind of read-only layers. And any read and writes are going to sit on top of that. So that's after it's actually running the application and doing anything it needs to kind of do, depending on the application, of course. So virtualization versus containerization. Here's a visual of how that looks. There's two different types of virtualization. You can think of this like VMware ESX or ESXi, right? You have your hardware, you have a hypervisor sitting on top of it, and then you have your virtual machines directly sitting on top of that. Or if you come from also the Windows world, you have hardware, perhaps you have Windows Server, then you're using Hyper-V on top of that, then you still have a virtual machine. Either way, in the virtual machine, you still have a guest OS, you have your dependencies, and then you have your application sitting on top of that. Compared to containerization, you have hardware, you have a host OS, you have a Docker engine that's allowing for this kind of support, then you have any dependencies and your containers kind of sitting on top of that. So within a container, you can have your application and your application dependencies all encapsulated, right? That's that runtime encapsulation. So advantages of implementing containers. And remember, we identified the pain points for developers in IT earlier. First off, you have fast iteration, you have agile delivery, it's immutable, you can put it anywhere. Then for IT, there's cost savings in it. I don't have to spin up all these virtual machines. I'm not having to maintain all this additional hardware. It's efficient deployment. Then you also have elastic bursting, which is if I did want to run in a private data center, but based on CPU demand or based on demand, I can burst into the public cloud and then scale back down. So now I'm going to go into a demo. It's going to be relatively a quick demo, but I kind of want to show you what's possible with containers and with some of these tools. And then we're going to talk about kind of what you're seeing. So the first thing I'm going to do is I'm going to bring up my terminal. By the way, if you do like my terminal, you can go to my GitHub, which is JL Deen, no relation to James Deen, so it's 2 E's. And I believe it's the .files terminal. You can actually go fork it. It runs on Windows Subsystem for Linux or Mac. But I'm going to go ahead and, let's see, we want to go to our CD draft demo. And I'm going to show you draft. And first off, draft works with Helm, works with Kubernetes. I'm going to show you the demo first so you can kind of be wowed, and then we'll go through PowerPoint so that you can kind of see what's going on. So I have two different folders in here. I have a Go application and I have a Python application. I'm going to go ahead and CD into my Python directory, and I'll do another ls. I have a very simple app file and requirements file. I'm going to open this up in code because code is my default text editor. And then I might have to zoom in on this real quick, but we'll see. So just to show you the application, very simple Hello World application, one dependency, which is Flask, and it's going to give me Hello Cloud Native eastpay. So it's great, but if I'm looking at this from a developer standpoint, I want to get started with containers, I want to get started with Kubernetes, but I'm really overwhelmed. I just like writing code. What do? I can go back over into my terminal, and if I'm using these tools, I can go ahead and do draft create. Draft uses draft packs, which is actually going to detect the language of my application. And now if I go back over into code, I have my Docker file. Draft actually wrote it for me. I also have charts, which Helm uses, and again, we'll talk about that. And it wrote all these templatized versions of my deployments. Everything is automated. It's built on best practices. I have a values file, which is kind of the knobs and dials for this Helm tool. And I can define my entire deployment right from here. And because I define it in this file, my deployment file or my ingress files will actually use the values that I define. So it makes it a lot more simplified and streamlined, right? It gets better. So if I go back over and I now do draft up, that's actually going to build my Docker image, and it's going to go ahead and deploy my Docker image locally. So I'm also, again, in my terminal, I can immediately tell what Kubernetes cluster I'm deploying to. I'm doing this all locally. This is my local environment. I'm not interacting with the cloud whatsoever. I'm not pushing it to an external repository or anything. So I just deployed it. I built it, I deployed it. All I actually had to write was my code. So now if I do draft connect, it's actually going to give me a location of where I can go take a look at my application as I'm debugging, as I'm working, right? So I can go down here on the bottom and actually paste this in, hit enter, as long as, there we go, hit enter, and now I get my return back from my Python application. And I told you, so number one, also if I redo it, and I'll redo it a few times, you can actually see the post right up here. Now I told you it works, it uses language packs to automatically detect your language, right? So let me CD out of this. I'm going to CD into the example Go. We will go ahead and clear this. Again, I only have my Go file. I'm going to go ahead and open that up in code. And you'll see it's one simple file. Again, it's going to be, I promise you, just as simple as the Python application. So this one I didn't personalize for you guys. It just says hello world. So again, if I go back over here and do again draft, create, it's going to automatically detect Go. If I go back over, I see again the same thing. It wrote my Docker file specific for that language. I have all my charts that are going to make sense for the application. I can even do cool things like add image pull secrets in if I wanted to. So to do that, I just simply add in pull secrets. I can go over to my deployment file. All of this will start making sense as you start diving into containers. And I'll touch on it a little bit. And also there's a blog post, by the way, that shows you this. But I actually can add in specs that if values for pull secrets exist, then go ahead and assign pull secrets. I can do the same thing if I want to, for the operations side, if I want to have networking added in. I can actually enable an ingress controller, which as of Lachie's latest release with AKS, and he worked with an amazing AKS team, you actually can now have HTTP routing set up on your cluster. All of that stuff is also available on my blog, but you can actually also enable an ingress controller, and then again, define your ingress YAML file to again spec out the rules and route your HTTP routing according to ingresses. So you no longer have to go out and manually assign this. So it simplifies the deployment process, and I can test everything locally. So I can still go ahead and say draft up, where it's going to again build my image, release my image locally, and then I can still do draft connect. So I'm able to work faster, I'm able to reduce that overhead or that bottleneck. And on top of that, since I'm testing with these same tools that my IT is also going to use, if I'm working in the same directory or same version control, I can work on my application as a developer, push my code up, and then the operations can go in and add all the networking and pull secrets and all the stuff that I don't need to know. That's not part of my job or my workflow. So that's a quick overview, and then we're going to go in and actually talk about what happened. So let's talk about container orchestration. As soon as my slide ends up showing. First off, elements of orchestration. You have scheduling. You heard me mention the word scheduler. You have affinity and anti-affinity. You have health monitoring, failover, scaling, networking, service discovery, and even app upgrades. So what do these words mean? You'll probably want to take a picture of this. I know it's a little bit wordy, but I want to make sure I give you the definition. Scheduling finds a suitable machine on which to run the container. Affinity is that I can specify where a set of containers should run, whether they should run nearby or sufficiently far apart for availability. I can do health monitoring, and actually as of one of our announcements at Build was you can actually have health monitoring in AKS with Azure Kubernetes Service. You have failover, scaling, networking, all of these tools that really streamline your process, whether you're a dev or IT. All of these practices, I should say also. So let's talk a little deeper. First off, Kubernetes is the de facto orchestrator. It's portable. You can use it public. You can use it private. You can use it hybrid scenarios. You can also use it in multi-cloud. It's extensible, right? So it's pluggable. It's modular. It's also self-healing. When you're using a managed version of Kubernetes, you have auto placement. You have auto restart, auto replication, auto scaling. It also empowers you to do more. Using container orchestration, as you saw even from my local workflow, I can deploy applications quickly and predictably. I can take that code, push it up into a pipeline, it's going to automatically deploy out. I now have a Helm chart that essentially is a bundle, a versionized package of my code, and it's going to automatically push out. Doesn't matter if I push it out locally on my system or somewhere else, it's all encapsulated, it's all nice and neatly bundled. I can scale my applications on the fly. As a result, I'm able to roll out new features seamlessly. And as I mentioned earlier, you can even limit hardware usage to required resources only. Let's dive a little deeper into Kubernetes. First off, what is it? It is an open source container orchestrator that automates deployment, scaling, and management of applications. Remember in the video, I mentioned bin packing? You have automatic bin packing. It is self-healing. You do have scaling. You have service discovery, load balancing. I kind of showed you where I can even enable ingress controllers and stuff. It's really powerful. I can have automated rollouts and roll backwards. Secret configuration and management. That's why I can store, on the demo, I was doing everything locally, but if I have a private registry, I can actually store the credentials for the private registry in a secret that's assigned to a namespace just for that application. And I can get really granular with that secret where I make sure it only has pull access and not push access. So somebody can't have that secret get compromised and push malicious code back up into my registry. So it's really, really flexible. It was originally designed by Google. It was donated to the Cloud Native Foundation. And as of March, it was actually the first project to have graduated from the Cloud Native Foundation. I believe as of right now, it's still the only project. You can go to CNCF to learn a little bit more about the requirements, but it's based on the system that they use, and it runs billions of containers per week. Billions. There are over 2,300 contributors to this project. It is open source. It's on GitHub, including contributions from companies like Google, Microsoft, Red Hat, Intel, and so much more. Mesosphere, which has their own orchestrator, DCOS, even they've gone in on Kubernetes. Why we call it the de facto one. So I often get asked, well, it's new, it's bleeding edge. Is it really practical to use in production? These are just a few companies that are using it. And I'm not done. There's more. Now I'm done for right now. So also Pokemon Go, so if you'll notice that. But again, Bloomberg, you have a lot of major news companies, and companies in general. On the previous slide, I love that Spotify is even using it. You have Twilio, Twitter. These are big companies that are relying on this orchestrator. So it is ready for production. Well, Verizon is? Yes, we have a person from Verizon. Am I allowed to use your logo in that? Can you find out? All right, cool. All right, so let's take a look at what makes Kubernetes awesome. First off, it's agile. If I have 8 servers down here, here's my orchestrator space. Here's my happy little IT dev person. I have all these apps I want to move into the orchestrator. I want to keep this person happy, right? The orchestrator makes it simple. It's agile. I can easily do that. But on top of that, it's also scalable. When I'm using a managed service like AKS, I can easily scale up to 18 servers. And now I can take these applications and move more over. So again, you do have that scalability. But it's also reliable. In the event that servers go down or nodes go down, it's actually going to self-heal, right? We have that self-healing work plane. So the applications are still up and running. It'll scale down what it needs, and it'll rebuild and add new workers and new nodes. That slide I already showed you. Sorry about that. So where can I get run Kubernetes if you want to? You can do Minikube. It's again a project by Kubernetes. You can also do Docker Edge. Cloud, Azure probably has some of the most options. We have Azure Container Service, where you can choose between Kubernetes, Docker, or Mesosphere, DCOS. Then you have Azure Kubernetes Service, and even Azure Container Instances, which we don't give you access to the nodes or the cluster, but you can run your single image in container instances, and it's actually backed by Kubernetes. Then there's also AWS with EKS, and then even GCP or GKE from Google. So flat out, what is Kubernetes or AKS, Kubernetes by us? It is your Kubernetes cluster, and it's managed by Azure. We take care of the control plane. So we recommend it because it's the easiest to use. It is the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands, and I like to argue it's technically 2. If you already are using Kubernetes, you already have something local on your system, you have kubectl installed, you don't have to run the second command, and I'll show you that. It's easy to manage. So you can have automated app upgrades, patching, you can scale your cluster up and down, and it's also self-healing, as we mentioned. Also, it is 100% upstream Kubernetes. That means that AKS on Azure is not a Microsoft fork or a Microsoft branch. This is 100% upstream, and it's full open APIs. To get started with AKS, you could use the Azure command line, and you would just run an AZ AKS create, specify the resource group name or the cluster name. It'll generate SSH keys when you specify that flag. So you do not have to provide an SSH key. This is the command I mentioned was optional if you already have kubectl. And then to get your credentials so that your computer or your system can communicate with your cluster, you would run the third command, which gets the credentials. And then you'll be able to run kubectl commands to see your node and interact with Kubernetes. To manage it, as I mentioned, it's super simple. You can scale up and down. You can scale it out accordingly. If I wanted to upgrade the version of Kubernetes, I just use the upgrade command with the flag of which version do I want. Or if I wanted to scale, I would use the agent count flag, and I could specify 10 or 50 or 100. By default, when you run the command on the previous slide, this one, it's going to give you 3 nodes. If I want more, I just use the agent count flag, and it adds more. Without AKS, in any instance, if you're not using a managed version of Kubernetes, this is what your Kubernetes instance looks like. You're responsible for the control plane. You're responsible for the master VMs. That means you're responsible for the hardware, the canonical upgrades, the scheduler that runs on there, if etcd fails, all these different components that make Kubernetes work. You're responsible for all of it, as well as the agent pool and your nodes. But with AKS, we take care of all that. You don't have to worry about it. So all you have to worry about is your applications, getting your applications out in the cluster, making sure everything's routed according to your business needs. So now I'm going to show you one more demo, and then Lachie's going to come up here and blow your minds with something that I don't understand. Before I show you the demo, I do just want to show you 2 slides, actually. So when I showed you Draft and Helm earlier, these are release automation tools. So Draft, as you saw, really streamlines the Kubernetes development experience, and Helm is essentially the package manager for Kubernetes. So that's why you saw charts. That's why you saw templates. Things were parameterized. Helm charts can be packaged up into tarballs, allowing for easy distribution. And Draft actually communicates and works with Helm. So when Draft uses language packs to detect that, that's why it's generating Helm charts. So let me go ahead and show you real quick. And as this shows, there we go. So I'm going to go over to here real quick. So I actually have a game called Cock Hunter. I don't want to quote this incorrectly, but I believe Lachie originally wrote it, or he wrote it with other people. It was owned by Deus. I believe it's still maintained by him. But it's a silly little game. I can shoot fish. What I love about it, though, is it makes it really easy to show in a demo, specifically because if I go down to the bottom here, I can see the commit ID. So I already deployed this. I already set it up in a pipeline. We talked about good DevOps practices. I'm going to show you the build here real quick that I ran. So I just made a change about 3 hours ago where I changed the game to shoot fish. I can also shoot lasers, so we can actually revert back and see that. You can see before that I did a change to lasers. So that was on a same app, different website. So, but because I can see, if I go to here, I can see the commit ID, obviously being DEF 1904. I mentioned that Helm and Kubernetes, these tools streamline that experience, right? So first, I love showing CodeFresh in this because they actually have really rich integration into Kubernetes. Rather than having to go look at my Kubernetes dashboard, I can get access to everything that's running in my cluster right from my CI/CD tool. So I can see I'm previewing this particular demo that you're seeing right now for a conference I'm doing in Napa next week, which is called Swamp Up by JFrog. So I created a namespace for them. All my applications, all my ingress controllers, my deployment files, everything is specific to this particular application. I can see that it's up and running. When I mentioned to you earlier about deployment YAML files, I can actually view what that YAML would look like for the service or for the deployment. So if you really want to sit here and write YAML and deal with tabs and spaces, by all means, go for it. But Helm streamlines that. So when I mentioned I like using CodeFresh, it's because I can also see my Helm releases, and it gives me a visual. I can see that already I have 6 revisions on my Helm upgrade or what I've deployed. So if I go and I can take a look and see the services, I can see I have 3 replicas. They're spaced across 3 different nodes. So if one node fails, my app's still up. If I go to history, I see the upgrade. But if I actually want to roll back to, let's say, the previous version of what I'm guessing was probably lasers, let's go ahead and roll back. Now I'm clicking a button in CodeFresh because it makes it easier to understand, but all that button's doing is running a Helm rollback command. and it's rolling back the release to the previous version. So I specify 2 arguments, and that's it. I don't have to deal with finding my commit SHA. I don't have to go pull new code. I don't have to log into a server or update packages. I just use a Helm rollback command, and it'll take care of the release for me. So when I refresh, should see, it'll take about 30 seconds to a minute to let that go through. If I keep refreshing this page, we should see the commit SHA ultimately change. So I see actually right down here, the commit SHA did, so it automatically rolled back, and I can hit start, and now I'm automatically shooting lasers. So in 30 seconds, I'm just able to revert back to whatever my change is, but on top of that, I can package up my Helm charts, put that in my version control, or put that in a private repo. I can do the same thing with my images. So everything is versioned and organized and indexed. But on top of that, as you saw with draft, it also made it a lot easier to manage. So this is a really quick demo, and I apologize for that. The longer version of my session is at Build, and it's free. You can watch it on YouTube. It gets into a little bit deeper about how all these tools are working. I only have 75 minutes, so all I can really do, or I only have 45 minutes. Usually I have 75. But all I can really do is just kind of blow your mind and show you Croc Hunter. If you want to be your own Croc Hunter, Lachie actually has videos where he's done this also with Jenkins. I've done it with VSTS. I wrote the YAML file for CodeFresh. All of it's on GitHub. You can go find me or find his GitHub and be your own Croc Hunter. Finally, also to get started, which is something we just announced earlier this week, is what's called the DevOps project for Azure with official AKS support. So to get started, you would click on the plus sign here. You would hit DevOps project. And when you choose the language of your choice, as soon as this pops up, we'll choose .NET, ASP.NET Core. When you hit next, you can actually select Kubernetes service. And what that's going to do is that's going to spin you up a Kubernetes cluster, an AKS cluster. It's going to spin you up an Azure Container Registry. It's even going to create a pipeline for you in VSTS, fully fleshed out, so you don't have to do anything. You can just drop your own code in, and the project on VSTS, if we go to the build real quick, actually uses Helm. And so it's actually using Helm best practices. For the release, it's going to do the Helm upgrade and all those commands I briefly talked about. For the build, it's actually going to even do things like Helm package. Let me show you the build real quick. I'll switch back over to the final goodbye slide, and I'll be done. Oops, not pause. Yep. You can do it from the portal. It doesn't require, but if you want to use ARM templates, I also have them on my blog. I partner with Lena Hall to write them. It supports both service principal name and key vault secrets. Depending on how you want to, because you also might want to get really granular with your AKS cluster. There might be certain other features you want to deploy, or if you want to use PowerShell DSC and you want to tie additional things into it, you can get more complex. But you can see this build an image, push an image, Helm, all these tasks will be set up for you actually. So probably the easiest way to get started if you kind of want to start playing is to check out Draft, check out Helm, and check out the DevOps project. I'll switch back over to my PowerPoint, and I just want to show you this slide. So you can go to helm.sh to learn more about Helm. And then I bet anybody can't guess what Draft is. Okay, you guys guessed it right. It's Draft.sh. So you can check out both of those websites to learn a little bit more. If you want to learn more about Helm charts, there are actually stable releases that are maintained by the Helm team. But you can go take a look at how those are written if you'd like to write your own, especially for your own projects at work. And then I already showed you the DevOps project briefly. Here's if you want to connect with me. You can check out my GitHub, Instagram, though I'm not going to lie, that's just pictures of my puppy and code sometimes and working out. So CrossFit, if you want to see pictures of CrossFit. Also Twitter, that's probably the best way to get a hold of me. You can always send me an email. I blog pretty heavily, so I blog usually about a bunch of this AKS Helm stuff. All the demos, even the Croc Hunter demo in detail is written out on my blog. I've showed it at various webinars and conferences. If you also want to see anywhere where I'm going to be or any member of my team is going to be for speaking, we have a website for that. And I believe finally that's it. So on the GitHub, just one comment, If you did want to check out the Croc Hunter one, you can check out, it's called Croc Hunter on mine, but I forked it of Lachie's. So then you can immediately go over and also check out his repos as well. So that's it. Thank you for listening.
Hey, thanks, Jessica. That was really awesome. Really appreciate you coming out here and taking the time to, show us how we could get started with Kubernetes. And I definitely would I trolled all your stuff already. There's a lot of good content, so I'd highly recommend getting out there and just picking it up. You get from 0 to 60 really fast.
One thing, just real quick. Obviously, this was only 45 minutes, and there's a lot of material. At Build, there were 2 75-minute sessions recorded, so it's about 2.5 hours of going a lot more in detail. All that content is free, as well as I think there was probably like over 100 other speakers, and the majority of that content, or a lot of that content, was all AKS. Some of it was Helm, some of it was really cool features that we're doing. So I encourage you to check out a lot of the content we have online.
Awesome.
The developer.microsoft.com, and then I believe also on YouTube it's the same link. But if you go, it'll just happen. I think go to developer.microsoft.com, click on that, or you'll see all the video content.
Awesome. Yeah. Hey, I really appreciate it. It makes a slow guy like me look smart, when I can go get information from you. So keep it up. Awesome. So we got one more speaker. We got Lachie Evenson. We worked together previously at Lithium, and that's where we kind of kicked off our Kubernetes journey. And then, the one great thing I always love about working with Lachie is sometimes I'd have these crude ideas, and then Lachie would go and just, run with it. And Kubernetes was one of those things where we were kind of like just wondering, like, we knew the container problem and the challenges with it. We love Docker and what it brought to the table. But then we started thinking about how do we scale this thing? How do we make this thing work? And like all the things that we see emerging now, like service mesh, like we were trying to build our own service mesh, and now thankfully the community is building some amazing tools around it. So it's great to have an individual like that who can go in there, dig in the code, and really find answers. And so tonight he's actually talking about something that even like Jessica said, I'm still kind of like, help me understand this. So I'll hand it over to him, and he's going to give us a dive into Kubeflow.
All right. Can everybody hear me? Woo! Okay. I would like to offer everybody a quick opportunity to get up and stretch their legs. Would that be interesting? Okay. We're ready to get back into it? You get your slice of pizza, you drink? Come on over and sit on down. I promise it won't take too long, and I'll try and keep it interesting. You got a moment? It's all right. Finish your conversation. I'm kidding. It's all right. All right. Who brought him? Get on with it? All right. We good? Everybody good? Refreshed? Ready to listen to me drone on? Okay, so I get the business end of the deal. Jessica brought the fun stuff. I'm bringing the boring stuff. Who here, let me cast a very small net. Who here would I identify as a data scientist? We have a data scientist. Okay, come on down. You're giving it. No, I'm kidding. So for everybody who's not a data scientist, we're going to be learning about a bunch of tools to make data scientists' life easier on Kubernetes. So hopefully you'll give me a pat on the back next time you see me. I don't know, this guy. He may or may not. Is anybody supporting data scientists? Is anybody interested in data science? Okay, we got a bit of, okay. So ML, it's obviously eating the world. All the large conferences this week, we're talking about AI and how AI is going to change the world. And did anybody witness the Google conversation where they would never do that in Australia because Google AI would never be that great to be able to understand an Australian native speaker. Okay, so what I'm going to do is go through Kubeflow, which is a project designed to create some tooling around this great platform that we have in Kubernetes that Jessica's just shared, and solving problems around getting data scientists, getting models out of their mind and onto Kubernetes, getting them trained, and starting to see how they can actually meet your business needs. So stay tuned. I wanted to give some context here. This is a fun slide that one of my colleagues made. But one of the things I had the pleasure of doing was working with OpenAI, and OpenAI's logo was up there on Jessica's slides. But OpenAI is an Elon Musk company which has the kind of charter to go outside of all these sovereign big companies and big public clouds to actually build AI for the benefit of mankind. So what I actually did was help them build their infrastructure, and all their infrastructure is built on Kubernetes. So there is a world out here today where folks are solving machine learning problems on Kubernetes. So we're going to talk about Kubeflow and how that works. Now, if you're interested, I will make these slides available at the end, so don't worry too much about grabbing this link. But OpenAI do a great job of blogging about how they're running Kubernetes, and they actually run their clusters on Azure as well. So that's a benefit for me to be able to help them with their 2,500 node cluster. A little bit about me. My name's Lachlan, Lachie, same person. Say it like lock and a key, not Lachie. It's not Rocky, it's Lachie. But that's okay. I've lived in many different countries. However you want to say it, hey you's probably still okay. I'm a program manager. What I do is actually take care of some of the services that Jessica was mentioning, AKS, ACS, but typically I'm out in the field working with customers and helping them get their workloads onto things like Kubernetes and our container services. This talk will not be about Azure or all open source. We happen to have Kubernetes offerings. If you use them, that's great. And we're trying to make it very easy for you to consume data science workloads on top of Kubernetes on Azure. Jessica also mentioned you can follow me on and my ramblings on Twitter. I also have a YouTube channel where I go down and actually live code these things and build these things and show you how to problem solve. So if you're interested in how you can do HSM-backed encryption, encrypted secrets in Kubernetes, I have a video on that just for an example. So feel free to grab that channel and consume at your own leisure on the weekends. Don't binge watch it, please. Not good for your health. Agenda. So what I want to get through in 30 minutes, yes, is talk about what developers have today and data scientists have today when they're doing machine learning on Kubernetes, and why there is actually a need for tooling like Kubeflow on top of Kubernetes. We have foundations in here. This is a larger deck. I can skip over that because Jessica did a fantastic job. And everything is a repo. This is worthy of popping out here. But you can actually follow along at home when you go back. We've built a whole lab here for you to take on. It's all broken down into modules where you can go through and follow through everything that I'm talking about tonight and recreate it at your own leisure on a Sunday afternoon when you're bored. Okay, so don't worry too much about it, but I'm one of those people that loves having a repo that accompanies a deck of slides to get back to where folks are. One of the things Joe imparted in me. Thanks, Joe. So this is all for your own taking. When I leave, you won't be forgotten. You can do it at home on your own. I'm going to go through some very compelling demos as well. So I want to show you what Kubeflow does, the problems it's going out to solve, and show you some real live machine learning training, some model training, some model serving, and some different ways you can interact with different code paths that we have out there. We don't need to set up a Kubernetes cluster. Let's assume you have one. If you don't, you can see Jessica. She can teach you how to get one. But all Kubeflow needs is a Kubernetes API. It doesn't matter how you get it, whether it's on-prem. My on-prem is Azure. Your on-prem may be something else. Whether it's another cloud provider or whether it's Minikube, this will all work as long as you have a Kubernetes API. So don't feel like you have to run something on AKS. That's certainly not. All right, so we have one data scientist. Hopefully some other people will learn about the data science workflow here. But typically what a data scientist has to deal with is a data set. So that's a data set of objects. So images, if you want to identify what a crocodile is, for example, if we're going on the crocodile theme, you need a data set to actually train a model to be able to identify things. So you need large amounts of images to say what is a crocodile and what isn't a crocodile. You tell the model what is a crocodile, that's called a target. And you also tell it what is not a crocodile, and then the model will go through and actually filter it through, and you can determine how accurate the model can predict what a crocodile is and what a crocodile is not. So this is talking about data sets, bottlenecks, and storage bottlenecks here. So these data sets get to very large sizes, terabytes, petabytes, and we're not going to actually solve them in Kubeflow today. We're going to be talking about that inner loop and the tail end of this. But I will point you at some great projects which take care of creating data sets and grooming data sets to have the right metadata so that you can feed them into models like these. Okay, so model development and training. So who here knows what an ML model is? Does anybody know what a model is? Yes, up in the back. Yeah. A bot? It's a model. It's a model, exactly. A model is a model. So that's all I have to say about that. No, so a model is a piece of code. It's very mathematical in background, and basically it's a way to identify. I've heard some really great analogies. Let's say you want to identify a picture of a bus. You may say a bus consists of wheels, so you may have something that can identify wheels. You may have something that can identify boxes, because buses are usually boxy shape. You may have some elements that can identify windows being transparent, grass, roads, any situation that you might find a bus in. A model can handle all that knowledge and boil it down to identify this is actually a bus if you're doing image processing, for example. So that's a model. But typically how you create models and train them is you develop them, you give them training data, you develop them, you give them training data until you get an accuracy that you're comfortable with. Do you want to be able to 80% of the time correctly identify a bus? Or is this life dependent? Do you want to be 97%? This is how you would keep training and seeing how accurate you can get your model over time. So you want to make sure that if I put a different type of bus that I don't think is a bus, I want to make sure I don't give you a false positive on that. Now, these are things when you talk about self-driving cars that are actually really, you want to make sure, I saw Google, a person dressed in a dinosaur suit standing on the sidewalk is not identified as a dinosaur, it's a human in a dinosaur suit. So these are common things that you actually have to deal with in machine learning models. But the impetus there is you develop a model, you train it, you have a look at the accuracy, you give it better data. So you put a picture of somebody in a dinosaur suit on the sidewalk so that it can correctly identify right from wrong. And then serving. So once you actually develop this model, you train it, you actually basically freeze that model and you serve that model. So you put data into that model, it gives you a result. And I'm going to show you how to serve it. So Kubeflow deals with model development, training, and serving. It does not deal with data preparation at this point, which is getting your data set or your image cache if we're dealing with images. And finally over there, the scaling and the serving bit. So when we take a look at why would this be of interest, can anybody guess why we'd want to do machine learning on Kubernetes? That seems interesting. You could do it in a container, you could do it on your laptop. Any interest as why Kubernetes might be a good place to run? Scale. So model training takes a lot of compute power, typically in CPUs or GPUs. Kubernetes is great at scheduling things. Jessica's video was great. You knock things over, you spread them out, you cut them up. So I like the oil slick analogy, an inch deep and a mile wide. So you can split your model up and train it on hardware in public cloud or private cloud and actually train your model. So typically what's happening in the life of a data scientist is they create a model, they train it, and they wait. They wait for the answer, which is how accurate was that model? Is that okay? Is this, change code, start again. Now, the length of that training run may take days, weeks, hours. Certainly when I worked at OpenAI, the data scientists would queue them up on Thursday afternoon. They would not have a result till Monday morning. So if you can actually have access to larger clusters, autoscalers, things like this, features in Kubernetes, you can actually speed up the iteration cycle between building your model, training your model, building your model, training your model, cutting, freezing it, and serving it. So this is the workflow that you need to think about as a data scientist. And as infrastructure engineers, this is what data scientists may come to you. I imagine we're here in Adobe. Adobe may have a field of engineers that may be looking at actually evaluating techniques such as this. Now, this model that I have up on screen, we're going to show this demo later, but basically you give it the Van Gogh image, and the machine learning model attempts to draw that image. So using machine learning, it will analyze the image and then attempt to draw it on its own and reconstitute that image. So we'll show how different training can actually lead to that. Now, this is actually a hyperparameter sweep. So instead of serially training one set of parameters, you can actually say, let's carve this out into multiple runs at the same time, and let's figure out which set of variables constitutes the greatest accuracy. Right, and there's some really cool techniques that you can do with that. So when you're getting high accuracy, you can actually go and cut off all the other hyperparameter sweeps and invest all that resources into getting that model that's really performing accurately, even more accurate. Is everybody interested? This good? Okay, we're going to get into some nuts and bolts. Question? Keep going? Good, okay, we're going to get into some fun stuff. So you'll be able to do this at home. So as I said, we've had Jessica up on screen, so I'm going to save save myself some time here. We don't worry about everybody's had an intro to containers, and I don't need to build a machine learning model in a container right now. You can do that yourself. Now, machine learning will work on your laptop. You don't generally have good GPU hardware on your laptop unless you're a gamer. Where's Touj? He might ask him. But you can run this in containers, and you can have access to specialized hardware through containers. Sorry, Touj, I didn't mean to call you out, but everybody knows you're a gamer here, right? Or just me? Okay, so how could Kubernetes help? This is really talking about scaling, parallel, resource consumption, and really getting access to some specialist hardware, right? So OpenAI scales up to 10,000 cores in a single experiment. You can actually scale your cluster up and accordion it out, train the model, and accordion it back down. Now, Jessica did mention something interesting, ACI. ACI with the virtual kubelet, you can do nodeless Kubernetes. So we're looking at ways of actually making compute more available in Kubernetes clusters without having to run up large fleets of VMs and wait for those VMs to spin up. Who's heard of TensorFlow? TensorFlow has a distributed model, so having a distributed TensorFlow model cutout will go into actually running that on Kubernetes. So you have a distributed framework running on a distributed cluster or distributed system. It fits together quite nicely. Intro to Kubernetes, we can skip over unless anybody's feeling, and creating a cluster. So for those that don't know, you can create clusters out of the box today with AKS. You just need to use a VM that has access to GPU hardware. So obviously there's some documentation here if you're interested in that. And there's also an autoscaler here. I'm not sure if that's been merged. This gentleman works for us as well. But there's a cluster autoscaler. So pairing this with an autoscaler is great as well. So feel free to take advantage. If you're short of a Kubernetes cluster with GPUs, you can spin one up on AKS fairly quickly and run through these demos. All right, so here's the nuts and bolts. We're actually going to go and run a TensorFlow serving job on GPUs on Kubernetes using, without using Kubeflow. So I want to just illustrate here how simple it is to actually do a single job on Kubernetes, but I then want to go into distributed TensorFlow. So just for those who are interested at home, and my Wi-Fi will come back. Break a Wi-Fi? What was that joke?
Oh, yeah.
Your Wi-Fi, a watch phone never rings? My internet will be back here momentarily. Okay. So really the idea of these labs that we actually published were they are self-guided, self-paced. They give you an overview of what you're trying to achieve in this lab. And you can actually go and build them on your own, or we have a section down the bottom where you can get the solutions to the labs and actually roll it out. So what I have carefully done here, in the interest of time, is actually set this up. Are those fonts big enough? We'd like bigger fonts, bigger fonts. Okay, so down the bottom here, in my bottom window here, I'm just going to run a kubectl get pods. So I have a Kubernetes cluster. Actually, I'll do a get nodes and show you what we've got here. So we should have an 8-node cluster. Each of these nodes actually have a GPU, and I'll show you how to identify that as well. Kubectl describe node, and we can give it the node name. And if we go up here and actually look at the allocatable or the capacity, you can see that we have an NVIDIA GPU there of 1. So each of these are single core GPU machines, and that item is schedulable by the Kubernetes resources. So just for some background there, I'm going to put a watch on kubectl get pods down here. Yes? GPU scheduling is per core at the moment. You can't do subcore. But stay tuned for Kubernetes 1.11 and device plugins. There will be subcore. We're working on that. So having 0.1 of a core, because you can have multiple processors consume a core depending on the CUDA library and the hardware that backs it. P100s, this isn't a P100, but a P100 can run 128 jobs or kernels simultaneously. So in the top, I'm actually going to be running my demos, and in the bottom, I'm going to show you what's happening under the hood here. So you can also, this demo will actually go through and show you exactly what we're doing here because I can't type it. So this is actually just showing you what nodes I have and how many GPUs they have. So I have 8 GPU nodes here. I didn't put it on auto queue. So I'm actually going to roll out this module 2 example 1. What this module 2 example 1, we can go and tail these log files. and I will show you what this has under the hood here. So while that is running, I'll pop back and show you the actual manifest here. So this is just a Kubernetes batch job. We're not doing anything with Kubeflow at the moment. And down here, we're running the MNIST dataset. We're training it on GPUs. The MNIST dataset is handwritten letters, recognizing if somebody writes an F, it will recognize as an F. The interesting thing is that we're requesting one GPU here, and we also have these volume mounts. So specialist hardware has libraries and drivers associated. You need to mount them into a container. This is only an issue when you're using raw Kubernetes. When we go to Kubeflow, it automatically handles auto-mounting all those things in the right places. So you need libraries to access the hardware, the hardware being the NVIDIA GPU hardware. We're mounting them in from the host, okay? And we're saying I need one GPU to actually go and process this. So this is a standard Kubernetes batch job. And this should finish here. kubectl get pods. Oh, I must have blown my job up here. Let's see why it died. Okay, it was not compiled to use. So I've got a busted demo script here, but that's okay. We can continue. So you can run using native Kubernetes jobs, these batch jobs, and that is just fine. The interesting thing about it is, as a data scientist, you would need to know where to mount the drivers, how many resources you need, so on and so forth. And that isn't a great experience for data scientists who are not Kubernetes experts. Any questions about just running a simple job on Kubernetes? No? Okay. Okay. Yes, go ahead. So a deployment and a job, the question was, what's the difference between a deployment and a job? Our deployments are typically service-based, so they run until they're deleted, whereas jobs run until the process exits, and they are not restarted once the process exits. So think of it, that job was actually training an MNIST dataset, which is basically passing through all those handwritten letters and training it, and once it exits, it's not going to be rerun. It's just going to stay exited successfully or exited failed state. My one exited in failed state. We're going to move on to Kubeflow now, so you're going to see a little bit of value that Kubeflow adds. So as this says, you have to take care of the drivers. This isn't really a concern of a data scientist. They don't really care about where the drivers are and where they're mounted. This is more an infrastructure engineer. So what we've actually done is use custom resources. Who's using custom resources on Kubernetes? Custom resources, fantastic. So Kubernetes, you too? Oh, yeah, okay. So Kubeflow uses clusters, custom resources. It creates a custom resource called a TF job, so a Terraform job rather than a Kubernetes job. And what this does is a very high-level markup of what sorry, not Terraform, a Tensorflow job. I said Terraform, didn't I? Tensorflow, good. The other TF. The other TF. Okay, yeah. Dyslexia. So what it does is you can actually identify how you schedule out those jobs and how you want them to run without knowing the intricate details of Kubernetes under the hood. So I'll show you what a TF job spec looks like. Now, Kubeflow's kind of mission is to make it simple, portable, and scalable, so it should run on any Kubernetes cluster, irregardless of where you got it. And it's all open source. So if you go to Kubeflow, all these demos that I'm building tonight are taken from the demos in Kubeflow, but they're just collated in a way that I think gives you a little more context. Okay, so we're going to move over. Was there a question? No. We're going to move over to another set of demos. So now we're going to look at Kubeflow specifically. So doing the same thing with Kubeflow. Okay. My computer comes back. All right, here we go. Got to be a better way to get between. Not today, not today. All right, so what I'm going to do is actually go back up and take a look at the TF job. So we mentioned TF job here briefly, but what TF job actually does is the same thing, but for TensorFlow specifically. So in TF job, basically, we don't have to worry about the drivers. We just tell it the name here, and this is a single job with a single GPU again. The only difference you'll really notice here is that we don't have to specify where the drivers are actually mounted, which is useful in the case that you don't know where they are. So it's not the concern of a data scientist to know where these drivers are mounted. So we will go ahead and run this again, and I'll show you how it works. Now, before I actually came to show you this, I actually set up Kubeflow on this machine, on this cluster, I should say. So Kubeflow actually runs on Kubernetes, and it's a set of manifests that get deployed using something called KSonnet. So KSonnet is very similar to Helm. It renders templates in a very similar way, but it's a little bit more pluggable than Helm out of the box. So what you see in the Kubeflow namespace is we have 3 Ambassador. Ambassador is actually Envoy. So what they're doing with Kubeflow is building a nice integrated front end where you have an integrated set of ingresses so you can access these resources. We've got Jupyter Hub. Does anybody use Jupyter Hub? I'm going to go into Jupyter Hub a second. Jupyter Hub out of the box. So we have a Jupyter Hub there. You can spin up Jupyter notebooks out of the box. We have a dashboard for aggregated and distributed jobs, and we have this operator. So what this operator's job is to do is to look out for those custom resources that we're going to deploy and actually implement them, pass them, change them to TensorFlow jobs, and implement them in TensorFlow. So I'm going to back up here to the Kubeflow demo that we have here. Actually, I'll go to TF job, 6 TF job, and what we're going to do here is just create that example that I said. What's going to happen under the hood here is we should see this TensorFlow job come up down here, so we can see this has been spun up. So what's happening under the hood here is that we created this TF job called Module 6 Exercise 2. So as you go through the library, you'll be able to do it. You can see here that this is spinning up now. It will go through and actually process the same workload, that MNIST workload, and train it. You can see that it's detected that I have a GPU here, and now it's loading in the data set to actually go and train. So all we've done is abstracted the Kubernetes underlyings using jobs into something called TF jobs, and TF jobs, you will see when it comes to distributed training, are a lot more simple. So at the moment, this is going through and actually training the data set, and that has actually completed. So any questions just about raw TF job and what this might? We're building up to distributed TensorFlow. At the moment, we're just running single node TensorFlow. Did I hear we had some Jupyter? We got Jupyter Notebook folks in the house, right? Okay, so what we actually have, let me just do the Jupyter Notebook bit. Inside the Kubeflow namespace, we deployed this TensorFlow hub load balancer. It can be of type load balancer public or private, whatever you'd like. So we get a public IP here. We should be able to hit this, and as part of Kubeflow, we should have a Jupyter Hub site set up here. Does anybody use Jupyter Hub? Jupyter Hub is for spitting out Jupyter Notebooks, and Jupyter Notebooks are about having a collaborative space to write your models, right? So think of them like as Google Docs for writing machine learning models. So I'm writing a model with this chap over here, and I can start writing. You can have access to what I'm writing. You can have access to what I'm writing as well. So this is a very easy way to set up out of the box. So I'm going to call it Lachie. I'm going to create my own workspace here. We can start a server. We can give it, we tell it what version of TensorFlow we want to run, how much resources we need. We'll give it one CPU, 1 gig of RAM, and tell it that we want to land it on a GPU. That will happen in the background here, and I will go back to showing you the pods inside the Kubeflow namespaces. So you can see here that I've actually spun up, I'll highlight it. I've actually spun up a Jupyter Notebook there for me under the user Lachie. It's been running for 13 seconds there. And what I should see from here is that I have a Jupyter Notebook. Now I can start working. Does this look familiar to you? I'm not lying? Good. Okay. I should be able to actually start up a notebook here, and it's just a very lightweight way. Imagine how hard if he came over to the folks that run Kubernetes here or somewhere else and said, I need a Jupyter Notebook. Where do I even start in Kubernetes? I wouldn't know as an infrastructure engineer. Kubeflow gives you a very lightweight way. You can have a notebook, I can have a notebook, you can have a notebook. Very simple integration with Kubernetes. So this is all about, remember, it's all about making data science easy and lowering the barrier to entry for data scientists to actually start training their models so they can focus not on the infrastructure, but actually writing the models, because the folks that are the data scientists don't really give a crap, and I don't care if it hurts your feelings about Kubernetes, nor should they. Unless the fact that it actually speeds up their job, which they might then give two hoots. Okay, so that is TF Job, that is Jupyter Notebook and Jupyter Hub. Are there any questions about that? So what we're going to do here is, I'm going to talk over this a little bit before I go back to the slides, but we're going to look at distributed TensorFlow. So distributed TensorFlow is actually having your model and your data chopped up into little pieces and run across a wide number of workers. So the way this is facilitated in TensorFlow is you have a parameter server, which is, think of parameters like variables, so they're ways you can tune your model. You have a parameter server, which is responsible for distributing the parameters to all the workers and the masters, and then you have a master worker architecture under that. So if you try and think about that and defining that in Kubernetes, everybody needs to know about everybody else. It's a full mesh. But they need to know about each other by name, and it needs to be pre-configured before the job starts. It's not a dynamic registry. It's not like adding things dynamically. It's like, I want 50 workers. I need to know all their IP addresses, and the master needs to know all of them. He needs to be able to connect. He or she needs to be able to connect to it and actually interact with them. So you could imagine this getting really out of control, right? So we have a worker. So if you were to go and run this manually, you would have, you'd spin up 4 pods. You'd spin up a pod to be the parameter server. You'd spin up a pod to be a worker 1. You'd spin up a pod to be parameter server 101. So you would have to then go in and start the training job with knowledge of every other piece of the system, right? This is obviously not scalable when you're talking about hundreds of thousands of pods. So what Kubeflow aims to do is actually automate that whole process on behalf of the user. So the user only goes in and defines something along the lines of this. Sorry for the scrolling, but it's a lab designed to make you think, not give you the answers, but I'm going to give you the answers. But inside this same TF job definition, what we see here is replicas. What type of replica is it? What image do you want it to run? What type of replica is it? So basically in this, we have a master, a worker, and a parameter server, and they're all defined in this spec. This spec is read in by the TF job operator and actually creates a proper TensorFlow model and splits it up, right? So as a user, again, you have a very lightweight way. I'll move over to the demo here, do the same thing. So I'll put a watch on this get pods. Okay, so I'm going to pop over to my distributed training now and do a demo here. So what this demo is going to do is apply that manifest that we just saw. The TF operator is going to pick that up. It's going to create the pods it needs, a master. Sorry, I'll go from parameter server, a master and a worker. They're all up and running. Okay, so if I had to do this by my own hands, they're erroring, don't worry about that. They're just waiting for the master to come up. If I had to do this by my own hands, it would be horribly difficult to actually get up and running. I'll kick that off again. The other interesting thing that we can do here is actually spin up tensor boards. So tensor boards introspect what's happening inside your job. So if we have a look here, I'll show you what we've got. Kubectl get pods, and we should have a tensor board here. Actually, I'll kick this job off again. It died for whatever reason. Demos never do what you want when you're looking. That's fine. We'll kick this off again, see if it works this time. Okay. So I'm just going to reapply that same demo, which should create another. See if that actually runs this time. And what I can do with this tensor board here is create kubectl port forward So I'll port forward to this TensorFlow on port 6006. And I can pop over here and actually take a look at localhost on port 6006. Okay. So what we should see here is, well, I should see the data come in eventually, and I should be able to actually see how this model is actually being trained. In the interest of time, I'm going to keep moving. Is there any questions about distributed TensorFlow at the moment on Kubeflow? Yes. 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 So you can actually specify. So the question was, does it do the resource allocation for you? You have to allocate CPUs, GPUs, and memory out of the box, and that will take care of making sure that's guaranteed and scheduled the nodes that has it available. They are the only things that are schedulable against or resource definitions at the moment. Okay, let me just clean up from this demo. Now, finally, I was going to go along and take a look at a hyperparameter. So I mentioned earlier, in hyperparameter sweeps, the idea of a hyperparameter sweep is to actually run multiple versions of these models with different input variables and actually see which model gets trained to the greatest accuracy over time. So what you would expect in a hyperparameter sweep is different rates or different input variables, and you would create a matrix that says at learning rate 0.001, have hidden layers in your neural network 5, 6, and 7. So as you can imagine, the more hyperparameters, you get a matrix to test every different permeation or combination of all these different input variables. And the idea is you want to see, and data scientists will tell you themselves, a lot of this is kind of covering your eyes and hoping for the best. But as you build these models, these input parameters, you don't actually know what will be the best result to actually train your machine learning model. So a hyperparameter sweep, what it lets you do is run many versions of these models at the same time. And using a tensor board, you can actually see which one is giving you the most accurate outcome. So if you're trying to identify a bus, you will see at this hyperparameter 0.01 and hidden layer 7. So hidden layers, you can take a look on your own time, but this is about how much depth and how much granularity. So if you're identifying a wheel in 2 layers, you might identify that a wheel has a hub in the middle and has nuts in the middle that hook the wheel onto the hub. You might have code around how detailed. If you're identifying a human face, you might have a piece of code that actually looks for wrinkles under their eyes. It's how much level of depth until you feel you can form the accuracy that you want. That's what hidden layers are. So how much granularity into face detail do you want to go? Or do you just want to say if it has 2 eyes, a nose, and a mouth, that's a human? Or do you want to say, if it's has a beard, no beard? These are things that are actually in layers of your neural network to actually say, this is the depth of accuracy I would like. I'd like to know that that is a male of this age group and he has a mustache or something like that. So a hyperparameter sweep is around creating that matrix that tests every different combination of all your parameters. So when we set up a hyperparameter sweep here, I will go over to here. Same kind of thing. We will set up, we'll do a watch down here. So we don't have anything but a miniopod here. So we actually do this with a Helm chart. So we install this hyperparameter sweep, and what we should see under the bottom here is all these different combinations actually start to get spun up. And we can also go ahead and there should be a tensor board actually running as well. This tensor board is still coming up. I will, once it's up, create a port forward, kubectl port forward of that, and we should start to see. Okay, so I'll zoom in here. So what you can see over on the left-hand side here is all these different workers, and they're saying, this is at depth 6 of your hidden, and this is at learning rate 0.01. So that's that combination of these hyperparameters. Now, The interesting thing you will see come in here is, does this look like Van Gogh's image? No, that's not a good run, right? So at this learning rate, at this depth, I'm not getting Van Gogh's work of art from the source image, but you will see as this training goes on, we should start to see models appear that actually give us a better rate of depth here. So does anybody remember that image that I had at the start here? What we're trying to have this neural network paint is this work of art here by Van Gogh, and what we should see with a hyperparameter sweep, what hyperparameters actually yield the best result in this model, right? So we're starting to see colors that look similar, and this is where the training takes time as a data scientist. I will continue to reload this. Starting to see, this one is actually performing a little bit better. Doesn't quite look like it, but you could say, I don't care about this. This is not producing an image that I want. It's completely way off base. And you can actually, in later versions of TensorFlow, you can actually prune and reallocate resources to this version of hyperparameters and then reconstitute. So it's, in essence, taking out a level of variability and starting to say, well, this looks like a better way to model this. Let's isolate those variables and start moving on the other variables. So again, I have made this, there's a lot to cover here. This is machine learning. I appreciate that a lot of folks aren't in data science, but what you have here when your data scientists come and say, hey, we have a Kubernetes, I want to do machine learning, what can we do? You might be able to say, hey, let's take a look at Kubeflow. We can actually get you up and running. You want to do hyperparameter sweep? Here we go. So you can see some of these models here, they're starting to actually produce. This will eventually train to that work of art or very close to it over time. Any questions about hyperparameters? Yes. 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 Yeah. Yeah, so case on it. So the question was, you mentioned case on it, I mentioned Helm. So it doesn't matter which one you use to get the job done. They both create templated Kubernetes resources. What we built for that lab is, if you go and look at the demo upstream for that demo, it's copying, pasting about 1,000 lines of code. And we said, well, we could just put it in a Helm chart, but that's not upstream at the moment. Case on it is used to install Kubeflow, but you could certainly do that same thing with case on it. We don't have a preference either way. What you do, if you're using Helm, you can install Kubeflow with Helm. It's just not upstream at the moment. When there's a little bit of legacy here, so there used to be a project called TF Job, which now is part of Kubeflow, and everything was installed with Helm. When they moved to Kubeflow, somebody had a great idea of actually doing case on it, and they ripped all the Helm stuff out, and now everybody's talking about putting it back in Helm. But we don't mind either way. If you use Helm, you can do it in Helm. If you don't, that's okay. The other thing I want to show is there's a lot of other backends. So if you go and look upstream, we only showed hypersweeping, Jupyter, and standard TF jobs. But if you go and just go to the Kubeflow lab, Kubeflow actually has a lot of different plugins here. If you go to the components, so we have at the moment these different model servers. So we have inception data, so you can do the inception, which is model searching, but there's also Selden Core, Argo, different pipeline mechanisms to actually plug straight into Kubeflow. So if you're using different pipelining technologies, you don't have to be bound to using the ones that everybody uses. If you're an Argo shop and you want to use Argo, that's fine. And also they're plugging in different frameworks, PyTorch, and other things like that. So at the moment, it's just TensorFlow, because that was the most asked for in the beginning, but it doesn't always have to be TensorFlow. So if you're working with other frameworks, by all means, bring them. Yes, yes. PyTorch is coming in. They're also talking about supporting things like Onyx, which is portable model data set, so you can transform between the NTK, TensorFlow, and different things like that. Argo's there. Argo's there today. So if you go to the upstream docs, you can plug in Argo. In case on it, you say, I want to use Argo, and Argo will actually render all these things in Argo pipelines. I do not. I don't. We use it. We've used it. We've had good, yeah, we use Argo sometimes. We are having good feedback. And what I will say, the team that works with Argo are very responsive and very happy to work with the use case. So I suggest bringing it to them if you have real specific questions, only because they've been really helpful to us in our discovery. Is there another question? Yes? Yes. So a TF job is a Kubernetes custom resource. So it's a job that defines a TensorFlow job. And basically there's an operator. So there's a piece of code running in Kubernetes that watches for the create, the update, delete of these TF jobs. So, and then implements all the aspects needed to actually stand up a TensorFlow workflow on behalf. So it's taking a Kubernetes abstract and rendering it into something that makes sense for TensorFlow, right? As opposed to having just a regular batch job, and TensorFlow doesn't know what that is, right? So you start with one custom definition of what your job is, and then it's going to create your parameter servers, your masters, your workers, and attach them all together on your behalf without you having to finagle all the underpinnings. Yes. So I have, so the question was, what issues have I run into running compute-heavy workloads in production? So I did a talk with the Microsoft research team in Austin, at Austin KubeCon, which was about what did we see when we ran up these models at large scale in production. And we go in depth. The biggest issue I've seen in relation to machine learning is models aren't linearly scalable yet. So as you add more resources, your performance doesn't go up at the same rate. So you end up paying for a lot more resources than you can actually use. So a lot of the work and that's for a number of reasons. A lot of it is around these hyperparameters being passed around to all the workers. These gradients, so the deltas, as these models are changed, the parameters are changed, and these parameter sets need to get moved around the network. This can cause a lot of network bandwidth usage. So networking can be a big problem. Actually getting jobs running and filling GPUs can be a problem. If you don't have enough data or it's not getting to the GPU fast enough, you can have idle GPUs. I would say storage is the third one. So writing these checkpoints to data stores and having them aggregated. Often these checkpoints are petabytes of data, and having that in a way that a data scientist can actually go and serve that model. In the interest of time, I'll wrap this up, but the last thing is serving. So what you want to do is after you train these models, you want to freeze them and you want to serve them, right? So you want to have an endpoint that you can go and submit a picture of a number or if whatever your machine learning model does and actually give you the result. That is the number 7, right? So TensorFlow serving does this. In Kubeflow, we can do serving. So we take that model that we trained and we go and push it into serving, and then we get an endpoint. So Kubeflow also handles TensorFlow serving. So it will take that model, you will load it into a TensorFlow serving container, and you will have an endpoint on Kubernetes that you can then go and hit. Now, I will show you quickly what that looks like. I do have it deployed here. If you're interested, you can ask me about it afterwards, but I'll show you quickly what that looks like just in the docs here. So if we go to serving, okay, so what you would do is run up, this is the client, so you would say, give me the host, so this is a public endpoint. Here's a picture of the number 7. You're going to submit this using the MNIST client, which is MNIST is the data set and the model that we've served. And what you would get is an output of something that looks like this. It would say, you sent me this, I detected this, and I predict that that is the number 7. Right, so this is the MNIST, which is handwritten numbers and letters. You should be able to send it a picture of a number, and it should be able to predict effectively what number or letter that you've actually sent it in that's in that image. That is TensorFlow serving. That effectively rounds out the suite. Now, what I would like to finish on here is with Kubeflow is 0.1, so it's still very early stages. But if you're interested in rallying with us and you have your use cases here, You can come, it's open source. We invite you, bring your workloads and help us make it better and tell us where we can improve on. So I will put these slides up online so that you have access, but you have access to those labs, and I've also recorded all those demos. So if you want to go back and watch the demos, we have them all recorded as well so that you can actually follow along at your own pace. So all that's open source. Take it, play with it, have fun with it, and learn what Kubeflow can do. I will post a link, so don't worry about typing too fast. I see that guy typing like, shh, gotta get those notes. Any questions? Yes. Yeah, so the question is about kind of cascade events and jobs and having the result of one thing become the input of another. Not yet. If you have that use case, feel free to come and help us build it. I think it's totally possible, and certainly Kubernetes can do it. It's just around rationalizing what we actually feed to you as the end user as to when to create that cascade. And I think a lot of it is coming around in TensorFlow 1.7. There's a lot around pruning, hyperparameter sweeping, when you see things that aren't getting the level of accuracy, killing that job off and reallocating the resources to the one and actually isolating those hyperparameters that you're finding giving you the most effective result on your train. Yep, that's exactly what's there, and I have seen it demoed. That's in TensorFlow 1.7, where you can auto prune based on some thresholds. So it's basically, if I have these hyperparameters and they're not performing at a level over some specific amount of time, kill it and go with the one that is, and use its parameters, and then keep going, and as it forks out, kill all the standard deviations or anything that falls outside of the anomaly that you're trying to look at there. So it's getting a lot more intelligent so that you can actually train your model a lot more efficiently and not so sequential in parallel, and actually not waste cycles training with hyperparameters that aren't actually yielding the result you want. But that's really in TensorFlow. Kubernetes could probably expose it. We work on that. Thanks for the question. Anything else? Well, thank you very much. Hopefully this was insightful, and thanks for having us. Thank you.